Hello everyone! In this video we will work out together an exercise about how to calculate the change in pH when a strong acid is added to a buffer solution. In this exercise the question is to calculate the change in pH when hydrochloric acid is added to a formic acid formate buffer solution. The question is, a buffer solution is made from 0.30 mol formic acid and 0.25 mol sodium formate in 1 liter of water at 25 degrees Celsius. By how much will the pH change if 50 milliliters, 0.2 mol per liter of hydrochloric acid is added? The first step is to calculate the pH of the buffer solution before the hydrochloric acid is added. This can be done by using the formula pH plus pKa plus the logarithm concentration of base divided by the concentration of acid. The value for pKa can be found easily in any textbook. For the acid-base couple formic acid and formate, this value is 3.75. The concentration of base is 0.25 mol per liter and the concentration of acid is 0.30 mol per liter. When we fill in these values in the buffer formula, we find that the pH of the buffer solution is 3.67. This is the pH before the hydrochloric acid is added. When a strong acid like hydrochloric acid is added to a buffer solution, the concentrations of the formic acid and formate ions will change. Formate ions will receive a proton, forming formic acid. The concentration of the acid will go up. The concentration of the base will go down. This can be depicted in a reaction equation as shown on the slide. Next, we calculate the amount of moles of hydrochloric acid that is added. When we multiply the molarity of the hydrochloric acid with the amount of liters that is added, we find that 0.01 mol of acid is added to the buffer solution. Now we can calculate the new concentrations of formic acid and formate ions. The concentration of the formic acid will go up by 0.01, while the concentration of the formate ions will go down by 0.01. The pH of the buffer solution after the addition of the hydrochloric acid can now be calculated. We again use the buffer formula to do this. When filling in the numbers, we find that the pH is now 3.64. The change in pH is simply the difference between the pH before and after the addition of the hydrochloric acid. The answer to this problem is 0.03, which is a very small number. This shows that a buffer solution is capable of resisting significant changes in pH when a small amount of strong acid is added.